Ever get that feeling time just flies by faster as you get older?
Yeah,
Summers used to feel endless, and now it's boom, another year gone.
I know exactly what you mean.
I feel like everyone's always pondering that, right? But what if it's not just us getting old and nostalgic? What if it's like a real clue about how time itself works? Like we're starting to see the code beneath the surface.
Oh, that's interesting.
And that's what we're diving into today with Stephen Wolfram's ideas.
Yeah, his recent article.
Exactly, because he's all about this idea that time, it might not even be fundamental.
Yeah, like it emerges from something deeper.
Yeah, and that something deeper, at least for him, is, get this, computation.
The universe is a giant computer.
I know, right?
It's a big idea.
It is, but stick with us here because he lays out this whole thing called computational irreducibility. And honestly,
Makes you think about everything differently.
totally. See, we
Yeah.
usually treat time like it's this dimension.
Like we're moving along a ruler or something.
Yeah, exactly. But Wolfram's saying, hold on, what if it's more like the unfolding of a computation
Where each moment is like a new calculation.
based on what came before? Yeah.
Exactly. So instead of a straight line.
It's more like this constant flow of calculations.
And that's what creates the reality we experience.
Moment to moment, yeah. Okay, the universe is like this giant computer that's always crunching numbers, and time is just like the readout.
That's a good way to put it.
But where does this irreducible part come in?
Okay, so imagine you're baking a cake.
Lucky.
You've got your ingredients, those are like the starting conditions.
Yeah.
Then you've got the recipe.
The rules, yeah.
Exactly, the rules for how those ingredients interact.
Mix this, bake that at this
Yeah,
temperature.
each step, each little action is like a computational step.
Changing the ingredients one step at a time.
Until, boom, you get your cake.
The universe is baking this giant cosmic cake, and time is the baking process itself. Not the ingredients, not the oven, but the actual baking.
And it can't just skip steps.
That's the irreducible part.
Yeah, you can't just throw everything together and hope for the best.
A cake made of raw flour and eggs?
Exactly, wouldn't work.
Yeah.
That's computational irreducibility in action. We
Oh.
can't just jump to the end result.
Each step is essential.
You got to go through the process in order.
So time has this direction, this flow, because the universe is working through these irreducible calculations step by step.
Precisely. And that's why we can't just fast forward to the future any more than we can instantly bake a cake.
He even uses those visual examples in the article, remember?
Oh yeah, the simple versus complex patterns.
Yes. One side of the grid is predictable, almost boring to look at, but then the other side,
It just explodes into this cascade of complexity.
constantly changing, yeah.
And that's the key difference. That simple, predictable side. That's a reducible computation, easy to predict.
Like figuring out what a simple clock will show a few minutes from now.
Exactly. But the complex side, that's more like our universe. It's full of these irreducible computations happening at every level. So many factors, all interacting in unpredictable ways.
And that's why we can't perfectly predict the future, no matter how powerful our computers get.
Exactly. Because you can't shortcut an irreducible process. Yeah, we're just getting started.
Because if the universe is computing everything,
If it's all just calculations.
then why don't we know the future? We're part of the system. Shouldn't we be able to see the code?
That's the catch.
Mhm.
We're not just observing the computation. We're part of it,
Yeah.
subject to its rules, just like any other part of the universe.
So we're like characters in a video game, trying to figure out the game's programming while still playing it.
And just, you can't build a computer that perfectly simulates itself.
We're also limited in how much computing power we have.
Oh, absolutely. We're trying to read this book
Okay, I like that analogy.
where each page is the result of this super complex calculation, right?
Yeah.
Based on everything that came before.
So we can only read one page at a time.
Exactly. At our own pace. So the story, it unfolds for us gradually.
Yeah, surprises, yeah.
And plot twists we couldn't have predicted just by looking at the first page.
So the universe, we experience it as this constant unfolding.
Yeah.
Because we're like stuck with our own little computers up here.
It's humbling when you think about it.
It is. So we're like those characters in the simulation.
But here's the thing, though.
What's that?
Those limitations, the ones that keep us from seeing the whole picture,
Yeah.
they're also what make time so interesting. Imagine if we could see the whole computation of our lives all at once.
Oh, man.
Every decision, every consequence.
Talk about taking the suspense out of life.
Exactly. It's the mystery, the surprise, the fact that we're exploring this computationally irreducible thing.
But that's what gives it flavor.
Exactly. And speaking of limitations, this brings us to another big thing about time.
Which is?
Why it always seems to go in one direction.
Ah, yes. Time's famous one-way street.
We remember yesterday's coffee, but tomorrow's is a total mystery.
We can't just hop in a time machine, relive the past, or get a sneak peek at next week's lottery numbers.
Wolfram actually connects this whole arrow of time thing to a few big ideas.
Lay it on me.
One of them being the second law of thermodynamics.
Okay, now remind me, that's the one about entropy.
You got it. Things tend to go from order to disorder.
Like my desk.
Exactly. Think about a messy room, right?
Well, I know the feeling.
Easy to go from clean to messy, but to go back.
You need a plan. Some energy.
Effort. You got to follow a specific set of instructions to restore that order. It's not spontaneous.
So entropy's like a universal one-way sign. Things naturally get more random, more chaotic.
And reversing that is really hard.
Which brings us back to
Computational irreducibility. Think of it like this. Every little event, every interaction in the universe, it adds to the complexity of the computation.
Oh, okay. So it's like, I'm picturing a deck of cards, start all nice and ordered, but you shuffle it once.
More random.
Shuffle again, even more. And the more shuffled it gets,
The harder it is to figure out the exact steps to get back to that original order.
you'd need a supercomputer tracking every tiny movement of every card.
And even then, it's practically impossible. That's the universe getting more entropic over time. The further we go, the more shuffled everything gets.
So going back in time, perfectly recreating the past.
It's like trying to unshuffle that deck back to its factory settings.
Practically impossible because of all the computations that have already happened.
And because our memories are part of this whole unfolding computation, too.
Ah, we've got a record of the path we took to get here.
The shuffles that led us to this point, exactly. But the future, it's a mystery. Those computations haven't happened yet.
Okay, that makes sense. But hold on. This is where it gets even weirder, right? Because this whole idea of a single timeline,
From
it's just our limited view. He suggests there might be multiple timelines happening at once.
multiple branches of reality, yeah.
Something straight out of sci-fi.
It's a mind bender, for sure. Imagine one of those choose-your-own-adventure books.
I used to love those.
But on a cosmic scale, yeah.
Yeah.
So instead of one story, there are countless branches.
Each one representing a different choice, a different path.
Exactly. Wolfram calls this branchial space.
Branchial space.
Okay, think of it like a tree with infinite branches,
Okay, I'm picturing.
all growing from the same trunk, right? Each branch is a unique timeline, a different way the universal computation could unfold.
Okay, so every time we make a choice, even a small one.
The universe splits.
Whoa! Creating a new timeline where the other option played out.
You got it. Infinite possibilities, constantly branching out.
Okay, I'm with you so far, but if all these timelines are happening,
All at once, yeah.
then why are we only aware of one?
Ah, that's where our own consciousness comes in.
Okay.
Remember, we're not separate from this computation.
We're part of the system, right?
Exactly. Our minds, our experiences, they're branching too.
So it's our consciousness acts as a filter.
In a way,
Yeah.
yeah. It collapses all those possibilities down to the one we experience as real.
Because we're following one particular branch through this crazy tree of timelines.
Precisely. We can only see the path we're on, the choices we've made.
The other paths, the other me's making different choices, they're out there, but we're not aware of them.
Hidden from view.
Ah,
At least from our view.
this is seriously blowing my mind. And we're not even done, right? He goes even further with this thing called the Ruliad. The Ruliad. Yeah, it's like the ultimate cosmic playground.
Imagine a space that doesn't just have all the possible timelines,
Okay.
but
Yeah.
all possible rules too.
So not just our universe, but with different choices made along the way.
It's bigger than that, even.
Whoa. Okay.
Talking universes where gravity works differently, maybe time runs backward. Anything you can compute, it's in there.
So our universe, the one we know and love, with its laws of physics and everything.
It's just one tiny island in this vast ocean of the Ruliad.
Mind-blowing. But okay, back to time travel for a sec.
Yeah, everyone wants to know, right?
If we're basically living in a giant computer program, can we hack it? Go back and change the past?
Wolfram would say it becomes a question of finding those exact computations within the Ruliad.
Like two identical snowflakes.
Exactly. Possible in theory because, hey, it's all just math, right?
But practically,
Given the sheer scale of what we're talking about, the number of computations happening every instant,
finding those two identical snowflakes is going to be tough.
to say the least, it really puts things in perspective.
Even if we had a time machine, it wouldn't be as simple as punching in a date and hitting go.
Not even close. We're talking about navigating a space of unimaginable complexity.
Okay, so time travel is probably a long shot. But what about that other weird time stuff? Like Einstein's relativity.
Ah, you mean how time slows down near massive objects?
Yeah, black holes and all that. How does that fit into this whole computational model?
Wolfram saying everything is computation, right?
Yeah.
Even gravity.
So a black hole is a really intense computation.
Kinda. Imagine your computer trying to run a simple program versus a really complex simulation.
The simulation's going to take more processing power.
Way more. It might even slow your whole computer down, right?
Oh, okay. I see where you're going with this.
Those intense gravity wells, those are like the heavy computation zones of the Ruliad. They take more steps, more processing power for the universe to run.
And that messes with time.
Exactly. Time isn't this separate thing ticking away at a steady rate.
It's directly affected by how much effort the universe is putting in at that spot in the Ruliad.
It's a pretty mind-blowing way to think about it.
Yeah.
Makes you look at time differently.
It really does. Even those moments when time seems to fly by for us personally.
Oh, you mean like when you're engrossed in a good book and suddenly hours have passed?
Exactly. Or that slow motion feeling when something exciting happens.
Wolfram might say, it's not just psychology. It's a glimpse into how our own level of engagement, our own mental computations,
affect our experience of time within the bigger simulation.
we're not just passively observing, we're part of it, shaping it with every thought and action.
We started with a simple question about why summers seem shorter as we get older.
And we've gone down quite the rabbit hole.
Multiple timelines, the universe as a computer program, this Ruliad thing.
It's a lot. But the biggest takeaway for me is time isn't just this background hum.
It's not just our clocks and calendars.
It's an active participant, a consequence of this incredible computation that's constantly unfolding.
And we're not just watching it happen, we're part of that unfolding. This deep dive has left me with more questions than answers.
Always a sign of a good theory, right?
It is. It makes you re-examine everything you thought you knew about, well, time itself.
And maybe about reality in general.
Next time I'm staring at a clock wondering where the time went.
I bet you'll think of the Ruliad.
I think I will. It's not just me being impatient, it's the universe, constantly computing, changing, and I'm part of that amazing process. Thanks for joining us for this deep dive into the mysteries of time, everyone. We'll see you next time.